In the last section, we spoke about how libuv provides a thread pool for offloading work to be done on very expensive function calls. In this section, we're going to modify our threads.js file and start to detect the presence of these 4 threads that are created for us automatically. So I'm going to go back over to my code editor where we have our 2 calls to pbk df2. I'm going to copy the bottom call here, and then I'm going to duplicate it down a couple of times. So in total, I want to have 5 separate calls to pbk df2. So here's console log number 3, and I'm going to update the console log. Here's number 4, and I'll update the console log to 4. And here's number 5, and I'll update the console log to 5 as well. Now I'm going to save this file, and I'll go back over to the terminal. I'm going to run this file again, and I'll see what happens. So back over at the terminal, I'll run node threads.js again. All right, so take a look at the results here. Do you see that little pause? Let me run this again. So we get the first 4 results, a pause, and then the 5th result suddenly appears. So this result right here is extremely interesting, and we can use these results to really divine some information about the thread pool and how it works. Now, one quick note, depending on your machine's CPU, you might see some different results here from what I see. So if you have a different machine than I have, you might see different results, and that's totally okay. Let me explain to you what's going on with my computer, and then you can kind of extrapolate what's happening to your own machine as well. So let's take a look at a diagram that's going to help explain what's going on. All right, here we go. Okay, so again, the first 4 calls took 2 seconds to complete, and then the 5th call took 1 additional second. There's really 2 interesting things to note here. First, notice that the first group up here all took the exact same amount of time, and it took roughly double what it had taken previously. So previously it took 1 second to get through the 2 calls, but now it appears to be taking 2 seconds. The second thing that I want you to note is that the 5th call over here only took 1 additional second. So that's very interesting behavior. Let's try to figure out why we saw the change in timing with the first group that ran, and then only 1 second to complete the 5th call. All right, so I'm going to show you a diagram of my computer. So this is a 2015 MacBook Pro. And by understanding the hardware that's inside of my computer, we'll have a better idea of why we saw that differing timings inside of all those function calls. So I'm using a MacBook Pro that was made in 2015. This computer has a dual core processor, so 2 separate cores. Let's first consider the original program that we wrote, where we had just 2 calls to pbk df2. So in that case, the first call was taken, and we can kind of imagine that maybe it got assigned to the first thread in the thread pool. That thread, we can again imagine that maybe this thread right here got assigned to running on core number 1. Then the second call to pbk df2 maybe got assigned to the second thread, and maybe this second thread got assigned to my second core. So we saw that these 2 calls each got assigned to 2 different cores in my machine, and they both took more or less exactly 1 second for each core to finish the hashing function call. So let's now take the similar diagram but apply it to the case that we just ran this in with the 5 function calls. All right, so here we go. So in this case, the first 4 calls each got offloaded to 1 thread that existed inside the thread pool. Now, here's where things start to get a little bit different. Remember how we had said when we spoke about threads much earlier that we can kind of get some level of concurrency with threads because our CPU has access to multithreading or hyperthreading, which allows it to kind of process more than 1 thread at once. When we just very briefly mentioned that. But that's actually the behavior that we're seeing right now with these 4 separate calls. So the first 4 calls to pbk df2 each get assigned to their own individual thread. Then thread number 1 and thread number 2 get assigned to CPU 1, or core number 1, excuse me, and thread 3 and 4 get assigned to core number 2. Our 2 cores, or my 2 cores, are only able to process these 2 threads at the same time thanks to multi-threading technology in my CPU. So because I've got multi-threading enabled, I can process more than 1 thread at the same time. However, each core still had to do twice the amount of work. It just had to do twice that amount of work at the same time, which is why we saw that it took roughly twice as long to calculate the hashing value for these first 4 values. Because at the end of the day, even though I have multi-threading enabled, all that enables my CPU to do is process more threads at once. It doesn't actually speed up the processing, it just allows for some amount of concurrency inside of the work that I'm doing. So we saw those first 4 calls get processed. They took roughly double the amount of time. And then once that was all complete, and those first 4 tasks were done, oops, let's undo that. Then Node was able to finally move on to the 5th function call. So maybe that one got assigned to thread number 4, and then thread number 4 maybe got assigned to core number 2. And because now core number 2 was only processing 1 hashing function call, this time around it took only 1 second. Okay, so I know that this has been some confusing stuff, but let's take a pause right here. We're going to come back in the next video and we're going to continue exploring this idea of threads in the thread pool by writing out some more experimental code. So quick break and I'll see you in just a minute.